In this episode, we take a close look at infrastructure as code, IAC, and why it changes the security game in both good and risky ways. Beginners often think of infrastructure as something you click together in a console, like servers, networks, and access settings that live outside the codebase. With IAC, those infrastructure decisions are written down as files that describe what the environment should look like, and then automation creates or changes the environment based on those files. This can make systems more consistent and easier to reproduce, but it also means mistakes can spread quickly and widely, because a single change can affect many environments. Securing IAC is therefore about making sure that infrastructure changes are reviewed, checked, and constrained in a predictable way so you do not accidentally create an insecure configuration at scale. The three ideas in the title work together. Reviews catch problems through human reasoning, policy gates block changes that violate agreed rules, and guardrails limit what can happen even when people make mistakes. Our goal is to explain what these concepts mean for a beginner, why they matter, and how they fit into a reliable delivery process without turning every infrastructure change into a painful slowdown. A good starting point is understanding what IAC really represents, because it is not just another way to write scripts. It is a shift in how infrastructure is managed. When infrastructure is defined as code, it becomes part of the same workflow as application development, which often includes version control, review, testing, and automated deployment. That can be a security advantage because changes are visible and traceable, unlike manual changes that can be forgotten or done inconsistently. At the same time, it changes the threat landscape because misconfigurations can be introduced through code changes, and those changes can propagate quickly across environments. Beginners should understand that misconfiguration is one of the most common security problems in real systems, and IAC can either reduce misconfiguration through consistency or amplify it through automation. If a bad configuration is encoded, the system will reproduce it faithfully, which is both the power and the danger. This is why the security approach for IAC focuses on preventing unsafe configurations from entering the codebase and preventing unsafe changes from being applied automatically. In other words, you treat infrastructure definitions as high-impact code that deserves rigorous handling. Once you see IAC as a fast-moving lever over real environments, reviews, policy gates, and guardrails become obviously necessary. Reviews are the human quality check, and in IAC they are especially important because infrastructure code can have security impact that is not obvious at a glance. A review is not just checking syntax, it is checking intent, such as whether a change opens access too broadly, weakens identity controls, or removes protective boundaries. Beginners can think of an IAC review as the moment where someone asks, if we apply this change, what becomes reachable that was not reachable before, and what becomes permitted that was previously restricted. Reviews are also where context matters, because a configuration that is safe in a test environment might be risky in production if it exposes sensitive data or critical systems. A good review process makes infrastructure changes visible to the right people, including those who understand security implications and those who understand operational constraints. It also creates an opportunity to catch mistakes that automated checks might miss, such as an unusual design choice that technically passes a rule but creates a risky architecture. Reviews work best when expectations are clear, so reviewers know what patterns are required, such as least privilege, segmentation, and secure defaults. When review is treated as a real safety step rather than a rubber stamp, it becomes one of the strongest defenses against accidental insecurity. Policy gates are the automated rules that decide whether a change is allowed to proceed, and they exist because humans miss things, and because speed can overwhelm careful review. A gate is a checkpoint in the delivery process where code must meet certain criteria before it can be applied to an environment. For beginners, a policy gate is like a building code inspection. Even if the builder is skilled, the system requires certain safety standards, and work that violates them must be corrected before people can move in. In IAC, gates often enforce rules about access controls, network exposure, encryption requirements, and other baseline protections that should not be optional. The advantage is consistency, because the gate applies the same rules every time and does not get tired or distracted. Another advantage is fairness, because the rules are transparent and predictable, which reduces arguments and last-minute surprises. The risk if gates are designed poorly, is that they can become noisy or overly strict, slowing delivery by blocking harmless changes or by generating confusing failures. That is why good policy gating is about choosing a focused set of high-value rules that prevent high-impact mistakes and are expressed clearly enough to be actionable. When gates are well designed, they speed things up by preventing rework and by catching issues early. Guardrails are broader than gates because they are not just pass or fail checks. They are constraints that shape what is possible in the environment. A guardrail might restrict which types of resources can be created, which regions can be used, which network exposures are allowed, or how identity permissions can be granted. Beginners can think of guardrails like the rails on a bridge. They do not tell you exactly how to drive, but they prevent a catastrophic mistake when someone swerves. In infrastructure, guardrails can prevent the creation of extremely risky states, like exposing a sensitive system publicly, even if someone accidentally tries. Guardrails also reduce cognitive load because developers and operations engineers do not have to remember every rule every time. The environment itself blocks the most dangerous paths. Another benefit is that guardrails make security more scalable because they protect the organization even when teams are moving quickly. They also support shared ownership because guardrails represent organization-wide decisions about acceptable risk, not individual choices made in the heat of delivery. If you rely only on reviews, a tired reviewer can miss something. If you rely only on gates, edge cases can slip through. Guardrails provide a durable safety net. The three elements together create layered protection. To understand how these pieces work together in practice, it helps to imagine a simple change like modifying network access for a service. A developer might want the service to be reachable for testing, but opening access broadly could expose it to the public internet. A review step could catch that the change is too permissive and ask for a safer approach, like limiting exposure or using a protected access path. A policy gate could enforce a rule that public exposure is not allowed for certain categories of services, blocking the change automatically if it violates the rule. A guardrail could restrict the environment so that even if someone tries to create a publicly reachable configuration, the platform denies it unless specific approvals exist. The point for beginners is that security is not one check. It is multiple checks that catch different kinds of failures. Reviews catch reasoning errors and design problems. Gates catch rule violations consistently, and guardrails prevent catastrophic outcomes when other layers fail. This layered approach is important because IAC changes move fast, and fast systems need multiple safety mechanisms. When these mechanisms are aligned, teams can move quickly without taking reckless risks. A key concept in securing IAC is the idea of secure defaults, because defaults determine what happens when people forget to set a parameter or do not understand a subtle choice. Secure defaults mean that the simplest path produces a safe result, such as denying access unless explicitly granted or using encryption without extra work. Reviews can reinforce secure defaults by rejecting patterns that depend on risky assumptions. Policy gates can enforce secure defaults by blocking unsafe settings and requiring safe ones. Guardrails can embed secure defaults by limiting the available options to those that meet baseline standards. Beginners should recognize that insecure defaults create a constant stream of preventable problems because people are busy and will choose the easiest option. When the easiest option is unsafe, you get recurring risk. When the easiest option is safe, security improves quietly without constant policing. This is one of the most practical reasons to invest in guardrails. They make the safe path the normal path. Over time, secure defaults also improve delivery speed because teams spend less time fixing the same kinds of mistakes. Another important dimension is identity and access control in infrastructure, because many of the highest impact failures involve permissions that are too broad. IAC often defines roles, policies, and permissions, and those definitions can grant powerful capabilities. Reviews should pay special attention to permission changes because they can create quiet but enormous risk, such as allowing actions that were previously restricted. Policy gates can enforce least privilege patterns by blocking overly broad permissions or requiring justification for high-impact rights. Guardrails can limit who is allowed to apply certain kinds of permission changes or can restrict the ability to create certain privileged roles. Beginners should understand that permissions are like keys. and too many keys in too many hands makes containment difficult during incidents. Managing identity risk in IAC is about making privilege changes visible, reviewed, and constrained. It is also about ensuring that changes to identity controls are not treated as routine configuration tweaks, because they can alter the security posture dramatically. When identity controls are handled with discipline, infrastructure becomes more resilient and incidents become easier to contain. This is a major reason IAC security is tied closely to governance and operational maturity. The review and gating process also needs a sensible approach to exceptions, because real environments sometimes require deviations for legitimate reasons. If every exception is impossible, teams will find workarounds, and those workarounds often reduce visibility and increase risk. If exceptions are too easy, guardrails become meaningless. A mature approach makes exceptions explicit, rare, and time-bounded, meaning the organization understands what risk is being accepted and when it will be revisited. Reviews can examine the necessity of an exception and propose safer alternatives when possible. Policy gates can require additional approval signals for exceptions, ensuring they are deliberate rather than accidental. Guardrails can support exceptions by allowing controlled pathways that require elevated authorization, rather than forcing people to bypass controls entirely. Beginners should see that the goal is not to eliminate all risk, but to manage risk consciously, especially when speed pressures exist. A clear exception process also improves delivery because teams know how to proceed when they hit a constraint, rather than getting stuck or improvising. This balance keeps security strong while keeping work realistic. Over time, securing IAC also means learning from incidents and near misses and turning those lessons into better rules and better guardrails. If a certain misconfiguration keeps appearing, that is a signal that expectations are unclear or that the system makes it too easy to do the wrong thing. Reviews can capture these patterns by documenting why changes were rejected and what safer patterns are preferred. Policy gates can evolve by adding or refining rules that address recurring high-risk mistakes. Guardrails can be strengthened by restricting dangerous patterns that have proven problematic in practice. Beginners should understand that security controls should not be static, because environments change and teams learn what works. The best controls are those that reduce repeated pain by preventing the same failures from happening again. This feedback loop is also what prevents security from becoming purely theoretical, because rules are shaped by real experience in the organization. When rules are grounded in reality, teams trust them more, and compliance becomes easier. This is one of the most important reasons to connect IAC security to operational learning, not just to policy documents. When you step back, securing infrastructure as code is about protecting the systems that create and change your real-world environment at high speed. Reviews provide human judgment to catch risky intent, design flaws, and subtle security implications that automation may not understand. Policy gates enforce consistent baseline rules so dangerous configurations do not slip through simply because someone was busy or inexperienced. Guardrails constrain what is possible so that even if mistakes happen, the environment resists catastrophic insecurity. Secure defaults, careful handling of identity and permissions, sensible exception processes, and continuous learning from real outcomes all strengthen these layers. For a beginner, the most important takeaway is that IAC makes infrastructure repeatable, and repeatability is powerful, so you must make sure the repeatable thing is safe. When reviews, policy gates, and guardrails work together, teams can move quickly with confidence, because speed is no longer the enemy of security. Instead, security becomes part of the delivery system itself, protecting both the organization and the people building the systems.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.